Hey everybody, Johnny here. In this video, we're going to look at how we could create some springs for our model and have those springs be responsive to the movements of our armature as far as compressing and extending and tracking along with our armature. We'll go through the process of setting up the geometry node tree and how we integrate them into our armature using drivers. So without further ado, let's jump right into it. All right, so to start off, we're going to just use our default cube as a base for displaying our geometry nodes. So we will just go ahead and pull up this section here and change it to a geometry node editor. And we'll add a new node tree. Now, we won't need the original geometry at all, so we're just going to cut that out. And so to make a spring, the easiest thing to do is going to be to use the spiral curve as our basis. So I'm going to add a spiral and plug that into my output. So one of the first things we'll want to be able to do, of course, is to set how wide the radius of our spring is and then how long our spring is. Let's go ahead and tie up our radius. So we'll pull an input in here. So let me just expand this out a little bit so we can see the names here. We'll bring in the start radius, and the start radius and end radius on the spring are going to be the same because the spring is the same width the entire length of it. So we'll just tie in the same radius to both. I'll open up my side panel here and change this from start radius to spring radius. I'm going to do a default here of 0.025 just so that we aren't creating something enormous every time we do this. Next, we want our spring length. So we will pull in another input into the height. And maybe we want our spring to default to 0.1. Actually, let's go a little bit smaller. Let's go with 12 millimeters for our default radius. And we'll leave it at 100 for our length. The next thing we'll want to put in here is the amount of rotations on the spring along the length of the spring. So that's going to be this rotation setting here. Now, because of the way we're going to design the ends of the spring, we want this to always start and end at the same point along the spiral. So we want our rotations to be a whole number. I'll pull in my rotations like this, but I want to change the type from float to integer. Here I've put a default of 25 and a minimum of 1 and set this to 25. So that's looking pretty decent. The next thing is for most springs that are extension springs, so springs that are being like pulled tight, and so and then they're trying to spring back to normal, as opposed to a compression spring, which is trying to be shoved in, and the spring itself is trying to get back out to its original position. We're building extension springs here. So many of them have extra spring loops just bent up at each end, and those become places to hook the spring onto a hook or a post of some sort. And so that's what we're going to do with this one. In order to create additional loops here, I'm going to create another spiral. This will have several of the same properties, like the radius is going to be the same. The number of rotations is going to be different, and we're going to want to be able to set that separately. We will pull in the rotations for the end, and we'll call this end rotations. And again, we'll want this to be an integer. And then we'll want our end height as well. And this will be the end length. Now that we have this new spiral put together, we can join it with the original one. So we'll use a join geometry here and add this in. If I go ahead and bring this down like this, we can see that this new spiral is not really doing what we're looking for, but that is okay. What we're wanting to do first is to tip it on its side. For that, we can simply use a transform geometry node, and we'll just rotate it on its y-axis by 90 degrees. And what we're looking for is this end here to match up with this end here and have it appear that these end loops have just been bent outwards. So first we're going to need to lower this down 1 radius's worth of position. So I'm going to pull out my translation node here and do a combine XYZ. And then if I bring in my spring radius to the Z, it moves it up 1 spring radius, and I want it to move it down. So I'm just going to need to multiply that by -1. I'll use a math node to do that, set it to multiply, and multiply it by -1. So now I'm adding negative the radius to the position there. That's already looking better. Now I also need to move it outward by 1 radius. And so that's our X direction here. And so if we bring the spring radius there, we can do that. Now, a lot of times if I'm multiplying by some constant or something like this, I really don't need this whole node taking up space. So what I'll do is I'll hit F2 while I've got this selected and rename this to something like multiply by -1. And then I can close that up, and it takes up a little less space. Now the next thing we want to do is rotate this spiral counterclockwise so that this end here matches up with this end here. Now we've already moved and rotated this spiral away from its origin point. So if we try to add any kind of additional rotation to this, it's going to rotate in ways that we aren't really expecting. So the best thing to do is to rotate this on its z-axis before we tilt it over on its side. So I'm going to take this transform geometry and duplicate it. And if I move it over here and zero out these settings, and I rotate this on the z, you'll see that is doing exactly what I'm looking for. And of course, I want to rotate this half a turn, so 180 degrees. So now if I bring in my end length a little bit and maybe shorten up my end rotations to say 2, it looks like that this has just been bent right here, and that these springs would have just extended the entire spring length had this all just been a straight spring. So now let's replicate this whole idea up on the top. We can use the same spiral we created for the bottom part in the top part as well. And we're going to need to transform this geometry as well. So we're going to grab this and we'll join this one in. We have this right here. We're going to need to move this up by the length of the spring. So I'm just going to duplicate my group input and bring it up over here just to keep things easy. So if I add the length of the spring to this, it moves it there. Then we're going to want to move it again up 1 radius's worth. So we'll do a math node and add in a radius. And we'll want to move it on the x-axis by 1 radius. And you can see here, if I bring this down around so that these match up, this is actually 0. So I can just get rid of this transform geometry, and that looks pretty good. Now let's go ahead and thicken this so that it is a wire. So down here, I will do a curve to mesh node and a curve circle node. Now that's going to blow up because my radius is really large. I'll bring my group input over and I'm going to plug this in here, and I'm going to call this my wire radius. If I drop that to something like 1 millimeter, we're getting something that looks decent here. If I change the length of the spring, you'll see that only the middle part is bending. The ends stay constant. So that works out better than using like a stretchy bone or something, where not only would the springs stretch out, but the internal structure of the wire would stretch out, the end hooks would also stretch out, and it really, if it got extreme, it really wouldn't look right. Whereas this one, you could stretch this one out pretty far, and it's going to look pretty good. Now let's take a peek at some place where it is not looking great. And that is right here. Bring the resolution down a bit to 10. And then if I start to bring out like the end length, you can see what's going on. Just because I lined up the end loop curves and the main spiral doesn't mean that those have become one spiral. We need a way to join those together so that this is one continuous curve, so that this artifact here doesn't happen. If you're newer to geometry nodes and you've seen the merge by distance node, you might think that that would be a good one to put here. But if we do that, we end up getting a input geometry has unsupported type curve. We can't just use this on a curve object. However, we can use a little trick where if we change this into a mesh first, merge by distance, and then change it back into a curve, we can in fact merge vertices of two separate curves into one and take those two endpoints, and they just become a middle point of a new curve. What I'll do is I'll do a curve to mesh, and then this merge by distance. And so now this point, which used to be just 2 points that were overlapping, has now become 1 point. And so if I take this and then go from a mesh to a curve, I can then use the curve to mesh node to solidify this. So now if I bring my end length in, I get a really nice smooth transition from one to the other. For ease of use later, we want to change a little bit of the dimensioning of this spring. And here's what I'm thinking. Right now, if I were to set the length of this node to some value, it's talking about this length right here, from the bottom of my initial spiral to the top of my initial spiral. Whereas really, I want the center point of one hook to the center point of the other hook to be my length. We're going to want to make the initial length of our spiral 2 radii shorter to compensate for these 2 loops that we've added at either end. And so that way it'll be at the middle of both of those. So let's go ahead and do that. If we come back to our original spiral here, and we take the height and we add a math node, we can take the height and subtract. And the thing we're going to subtract is the radius multiplied by 2. Now we could do this, what we've done here. We could also use the multiply add node, as we could take the radius, multiply it by -2, and then add the length. That's going to accomplish the same thing, just in one handy node. If you're more comfortable doing it with 2 separate nodes, you are certainly allowed to do that, and it will work. Now you can see that this is no longer correct. We're also going to need to drop this down by 1 full diameter, or double the radius as well. That was this z-axis here, where we added the spring length plus a radius to move it up. So now if we were to do the spring length minus a radius, we get the same thing. Let's make this a nice even number here. So we'll go with 100 millimeters. And if you can make it out in the video, we've got these slightly more pronounced lines. That would be a 100 millimeter mark here. Right now, the center of our object is still here at the transition point between the hook and the spring. And we want our center point to be at the center of our spring. But we want the center point to be here at the middle of our hook, not at the beginning of the body of the spring, because we're going to later want to measure, like I said, between the centers of the hooks. So if we want to adjust everything relative to the origin of this object, we can go all the way to the end, and we can do a set position node. Anything we add to this will simply move everything in relation to the origin. If I simply add in the radius, that's going to bump this whole spring up one radius amount, and that should line it up properly. So to the offset, I will do a combine XYZ, and then I will just add the spring radius to the Z. So now my 100 millimeters from here to here is the center point of my bottom hook to my top hook. So if I take this and rotate it, you see it's rotating around the bottom hook, and the distance then is going to be in relation from here to here. A few minor cleanups before we finish this. The first is we'll want to put end caps on our curve. So we'll do the fill caps on our curve to mesh. So that looks good there. And then we'll also want to be able to set the resolution of our wire, which is the curve circle. So here we'll do wire resolution, and you could drop this down to whatever you feel like. Like here, from a distance, this might look okay, but I've actually got this now down to a triangle. But you could get away with a whole lot less geometry, especially if this is going to be from a little bit of a distance and you set it as shade smooth. The other thing you might want to do is set the resolution for each of the turns of the spiral. And so we can drag in that resolution as well. And that will be our rotation resolution. And so you can see here, you could get some interesting shapes, or you can just bring it up to the point where it looks good and you're happy with the result. We don't need our geometry input because we don't actually use it, so we can get rid of that. We've got our geometry output, which we do need, and the rest of this looks pretty good. So I'm going to go ahead and give this a name. We'll call this extension spring, and I'm going to mark that as an asset, and I'm going to hit save. All right, let's jump back to our lamp file and see how we can add this in. Since I didn't add the spring and save it in one of my asset folders, I am going to need to append this. So I'm going to go to append, spring, node tree, extension spring. So now I have this in my scene. The next thing I'll want to do is just add an object here. So shift right clicking, I place my 3D cursor. I can just add a cube if I want to. I'll go to my modifiers, add geometry nodes, and then add my extension spring. We can see already I didn't set some of the defaults very well, but we'll live with that. Rotate this around and bring this into position. And now from here, I can kind of scale this up to my needs. So we're going to need more spring radius. Like that looks good. And then we're going to need more spring length. Once we have that in position, we can add more rotations if we want. We could change the wire radius and make the spring a little thicker. And we'll slide that in this way. So from a static position, that looks pretty good. But we want this to track with our object and to stretch accordingly depending on how the arm is moved. And so we get a realistic response from the spring. So I'm going to move this out of the way for a moment. And we can see we've got these two pegs on the model. And that's going to be our rotation point for our spring. So the very first thing we can do is add a couple of bones to those locations so we can use them as pivot points and tracking points and that kind of thing. And then I'll do a Control plus to just extend the selection. I could do a cursor to selected and then go into the armature and add the bone, or I can use my rigging tools to add bone at selected. And I'll just do that. I want it to be on the plus Z, and I can just click OK. I've got that one. And then I can do something similar for this one. So those look good. I'll jump over to my armature. I'm going to bring these down a bit. They don't need to be quite so tall. This peg is part of this front lower arm here. So I'll select it, select the front lower arm, and parent it, and keep it offset. This peg is part of the swivel, so I'll parent this to the swivel bone. I'll put our names on here. This bone will be called, this will be the bottom lower spring, and this one will be the top lower spring. Now I'm going to jump into pose mode just to make sure that those are moving like I expect them to move. So the top one looks like it's moving fine, and the bottom one looks like it's moving fine as well. So next, we want to take this spring object and we want it to follow this bottom bone. So what I'm going to do is I'm going to go into my armature here, grab my lower spring bone, select my spring, select my armature, and parent to bone. Now the next thing I will do here is I'm going to go into this armature, select the head of this bone and do a cursor to selected, then go back to my object and do a selected to cursor. So now in pose mode, if I rotate this bone around, we can see our spring moves with it. We can see that it is following like it should. The next thing we want is this bone here to always point to the top lower spring bone. And we can do that with a damped track constraint. So what we'll do is we'll choose our armature. We'll choose the bone that we want to track to. And we can see that we've still got a little bit of rotation on our spring here that we need to get rid of. So I'm just going to zero these out. We still want the 90 degrees on the Z so that it's pointing in the correct direction along the Z axis of the spring. So now if I move this, you can see it's pointing in the right direction. It's just not stretching. For that, we're going to need to add a driver. And the thing we're going to drive is the length property of our geometry node. Because you can see here, we can go in and adjust this and make it fit. However, we want this to be live while our model is moving. So here, if I right click on my length property and say add driver, this will open up this driven property window. I do have some other tutorials on drivers, so I'm going to go over this relatively quickly, but if you want more information on how to set up drivers, you can look through my channel and find those videos. The type of driver I want here is a scripted expression. The key part of our scripted expression is this variable, and it's automatically named var. And var is going to be based on some property within our scene. The thing that I want to calculate is a distance. And the distance we need to calculate is between the bottom lower spring and the top lower spring. So I'll choose my armature, and right here I'm going to say open the driver editor. That will open a permanent driver window for me to work with rather than always jumping back and forth between that little pop-up window. So the bone here that I want to choose is the bottom lower spring. And then object 2 is that same armature, but I want the top lower spring. This has made the spring quite a bit longer than it should be. The reason for that is when we created the driver, it was trying to keep the spring in the position that it was in when we created the driver based on the type of driver that it had created by default. So it had added this 0.755 to the variable in order to keep the spring in the same place when we added the driver. But since we made it that the center points of these hooks are the length of this spring, we want the distance between these two bones to be that length. So I can get rid of this plus 755, and immediately we can now close this window. We can see that this has now jumped and is connected here. The real test will be if I grab my control bone here in pose mode. My spring is working perfectly. Now for this bottom part, I'm going to duplicate this spring, bring it over here, and then for its rotation, I am going to go -90, and my bottom springs are working exactly like I want them to. And now the process for the top springs are going to be identical. I'll add my bones, shrink those down. This will be the top upper spring. This will be the bottom upper spring. I'll duplicate my spring here, and I will parent it to this bone. Cursor is selected, back to my object, selected to cursor. This bone needs a damped track. And if you look here in my rigging tools since my previous video, I've added a couple of additional constraints here. So if I choose this bone, then this bone, and do track 2, that will work just like adding an IK constraint, where the active bone gets the constraint and the inactive bone is the target. Now I just need to edit the driver because this is still pointing at the distance between those other lower bones. So here I will open my drivers editor, and the two bones here are going to be the bottom upper spring and the top upper spring. I'll check this to see how it's working, and I can see that it's not. The reason for that is I simply forgot a step. I didn't parent my new bones to my armature, so I'm just going to go back and do that real quick. The bottom upper spring here is connected to this disc, which is connected to the lower linkage, so I'll parent that there. And then the upper spring is parented to the upper front arm. Now if I go back, we see that that top spring is working as expected. Come into top view, move it over just a little bit, duplicate it, -90 for its rotation, and then move it out this way. Only show our controls. And sure enough, our springs are acting as we would expect them to. So that's it for adding springs to our lamp tutorial. I hope this shows you how you can use geometry nodes and interact with things like armatures using drivers, and how you can end up with a nice setup like this that's responding in a proper way, where only the part of the model is changing that should be when we're stretching it, and not just stretching out the model like the whole thing was made out of rubber or something like that. So this file will be available on my Patreon for my Patreon supporters, and for any of my YouTube channel subscribers as well. I hope you got something out of this, and I hope it inspires you to make something awesome. And until next time, I'll catch you later.